Good afternoon, everyone. Welcome to our webinar session today on analyzing large-scale assessment data. My name is Jonathan. I am collaboration facilitator at the Southwest Doctoral Training Partnership. Um, so really happy to bring to you today two presentations from researchers about how they did just that. Joining me today, we have our session chair, Professor George Leckie, who is Professor of Social Statistics, as well as co-director for the Centre for Multilevel Modelling at the School of Education at University of Bristol. Um, the session is recorded, as you can now see, is now in recording has now started. The caption is available for the session if you would like to use that. It is at the top of your screen. If you click more, you should be able to see that, but just be aware that it is auto-generated, so may not always be accurate. We will have quick fire kind of questions after each presentation, but hopefully we will also have around 10 minutes of general Q&A towards the end of the session today. So without further ado, let me introduce our first two speakers, Dr. Ioana Crivatu from the University of Birmingham and Dr. Ruth Spence from Middlesex University on their presentation on, let's have a look, on issues with using police data to investigate offending. Over to you two.
Okay, let's see if I can share this. Does that work? Does everyone can see?
All good.
Okay. Good, thanks. So Ioana and I are going to talk about using police data to investigate offending from a research perspective. So first, we're going to talk about the data itself, what it included, how it was formatted, and what we had to do to get it into a usable format. And then we'll go on to talk about some of the issues we had with it and some of the strategies we used to help us overcome these. So the data itself was collected as part of Operation Soteria. So this was a project to transform police investigations into rape and serious sexual assault by taking a suspect-focused approach. So Ioana and I worked on pillars 1 and 2, which concentrated on suspect-focused investigations and disrupting repeat offending. So as part of this, data regarding all the sex offences occurring over a 3-year period was collected at 3 time points. It was first collected in 2021, then again in 2022, and finally in 2023. So we got the data from 5 police forces in England and Wales. They shared it with us initially. Only 3 managed to get the data to us in time for the 2022 deadline, but in 2023, all police forces shared the data again. Although for one force, the data they provided us with wasn't usable for our purposes, and that's because every suspect and victim was given a new ID each time they appeared in the data, so we couldn't look at repeat offending. The criminal history was also provided for all the identified suspects that had sex offences. So the data itself was provided in multiple Excel files, and the different variables were provided in different tabs within these files as well. So you might have an Excel file with victims and another with suspects, and then within these files, the different years might be on different tabs. We were given details of the crimes, so that it would include crime type and outcome, and demographic details of the suspects and victims, and that would include things like sex, age, ethnicity, and victim-suspect relationship. The data was provided at a person level, so this means the data that was extracted by each police force was for every individual who was associated with a sex offence. We then used all the unique identifiers for the suspects, the crimes, and the victims to match up the different aspects of the data to make one big SPSS data set. The police forces didn't all provide the exact same data. So there was core variables like the demographics that were in there for all of them, but then there was other variables like dash ratings that were provided by some forces, but not all of them. The names of the variables were also different across the forces and had to be matched by what they were rather than what they were called. The police analysts were the ones who extracted and shared the data with us, and they had different ways of downloading it, which could result in us receiving slightly different data sets at each time point. So there was one case where a force provided less data at a refresh, and you'd expect there to be more. And we had a lot of back and forth trying to work out why that was, and we couldn't figure it out. So in the end, we just had to merge it with the older data set. So as you can see, the final data sets were really large. We didn't merge the data sets the first time round as data came in across the year, and we compared forces through doing similar analyses where the data was comparable, and then supplementary analyses where it was different. For all the refreshes, all the data was requested at the same time, and the same deadlines were given to each force, so we could merge these data sets. The numbers included here, or the numbers here don't include non-crimes and no crimes. They were excluded because they weren't part of our research remit. We also excluded unidentified suspects because without their identifiers, we couldn't determine whether they were repeats. Unidentified victims were kept in. So that's to give you some context about the sort of data that we were using. We'll now talk a little bit about some of the issues we faced when we were using the data. So as you can see, there's large amounts of missingness, up to 78.8% of relationships, and like over half of victim ethnicity was missing. So police used the sort of data that they were giving us for practical reasons, such as tracking investigative progress. And lots of the information that they collect in their investigations is contained within unstructured textual data. So practically for us, this meant that there was just large amounts of missing data, even for features which might be considered straightforward, like sex of the victim. And then as the variables got more sophisticated, so things like behavioral data for weapon use, vulnerabilities of the people involved in the crimes, the amount of missingness increased, and in some cases it increased to the amount that it was basically unusable. So for us, this meant that there are some analyses that just couldn't be done, and then some research questions that we simply couldn't answer. And also, when there's a large amount of missingness, it reduces the amount of power, so it makes it harder to detect significant differences. Also, the more missing data there is, the more it might reduce how representative your data is, or it can introduce bias. And this might be because that certain types of suspects, crimes, or victims are more likely to have that sort of missing data. So in order to address missingness, you can do a missingness analysis, which can enable us to understand the patterns, like whether data is missing completely at random or just at random, and also a bit about the mechanisms behind the missing data. So where data is missing completely at random, missingness has no relationship to any of the observed or unobserved variables. So that might be something like a data field that's just been accidentally skipped. And this is good because it doesn't introduce bias into the results, because any case is just as likely to be missing as any other. However, unfortunately, police data is unlikely to be missing completely at random. Where data is missing at random, the missingness is related to other observed variables, but not the actual variable that's missing. So this might be something like officers being less likely to record relationship type in cases involving family members when the victim is a girl. But because the sex of the victim is recorded elsewhere in the data, you know that like when the victim is a girl. For missing not at random, the missingness is related to the variable that is missing. So this might be something like officers are less likely to record relationship type in cases involving family members, but you wouldn't have the relationship type because it is the missing variable. So for missing at random and missing not at random, it's best to use strategies like multiple imputation or maximum likelihood estimation, and also sensitivity analysis. So sensitivity analysis is tests that you run where you can see how the results change under different assumptions about the missing data. For instance, if you change the imputed value slightly, and then you can explore how estimates and conclusions might change. So are the results still significant, and does the direction of any relationship change?
So I'll take over from here, and Ruth has already spoken about the missing values, and I'm here to talk about the other side of data quality, which is the sort of misclassified erroneous values that the police have. Because the data is entered incorrectly, and it has a lot of recording errors, and this is part in due to how the system, the police crime recording system, is created, what sort of system they're using, how easy it is to record data in it, and there are multiple sort of IT systems across police forces, and each system is used for different purposes, and they don't necessarily link up. But it is also erroneous because police officers just do not prioritize one's data entry. So I think in one of the latest reports, it was that only 95% of all sex crimes actually get recorded. And they also do not prioritize accurate data entry. And sometimes some types of crimes are more accurately recorded than others. And you will see that especially if you have, like we had, the criminal history of offenders where they go beyond sex offenses. Entries are also not updated as soon as new information comes to light. And from our conversations with the officers, particularly in sex offenses, they rely a lot on case files in their investigations, and they don't really go back to the recording system. And also in the system, there can be multiple variables regarding one broader aspect of the crime, and there can be inconsistencies between these variables. For example, for crime time, we got given home office code, home office comp description, home office subcode, offense title, and I believe there was one more variable for one specific police force. But most of the times these match, but not always. That was quite difficult to figure out which is what, and it is difficult to tell when data is inaccurate, what is the most accurate, and then what is most trustworthy. Another issue in terms of the most common errors that we noticed were ages for suspect and victim. Ages were with minuses or ages over what you would assume to be a natural lifespan. So from like -4 or -0.1, what was one, to like over 150. So you need to look then at the logic of those offenses. So for example, is it really possible for an offender age 2 to rape a victim age 18? So you might then have to decide what you treat as missing value and what not, and as an error. And once you make these decisions, some of the nuance is lost. It is also possible that someone is 110 and offending. So, but maybe that is a risk that you have to take. We also noticed that a lot of times the same person was recorded as both male and female. So then, Ruth, can you go to the next one? So then we would highly advise kind of cross-checking across all of the data that you have and trying to pull information from different variables that you have, as well as doing frequency and missing analysis. For example, some recording errors can actually be by design. Putting a 0 for an age can just be a placeholder for when the age is not known. Or also in terms of dates and times of the crime, sometimes the 1st of January or a time of midnight is a placeholder because they don't know exactly when it happened. And that's particularly a case when it comes to like historic data. So then you need to understand that in order, if you want to do like, for example, longitudinal analysis or time and dates based analysis. So you need to determine the frequency of certain responses and how certain values can be outliers, or whether the missingness analysis sort of coincides with other values, such as an age of 0 is put for victims and suspects that don't have any other information. You might also need to choose what is the most reliable source of information and what is missing the least in your data set. When it comes to crime times, for example, we advise always checking them and cross-checking them against the official list of notifiable offenses. And depending on how far your data goes, some offenses may have changed codes or may have been reclassified or renamed. So you need to understand those differences. Other sources of information, for example, looking at the sex and of the victim and the male, depending on the crime time. And you have to make decisions about a sort of a trustworthiness scale. So for example, if your subcode is deemed to be the most trustworthy, then is it then more likely that the victim sex is recorded erroneously, or is it the other way around? But whenever you decide to exclude based on an error, we advise that you do it for all errors of that type and document why and what was done. Can you skip to the next one? Another big issue that we noticed were inconsistency, and that is basically the vague and at times sort of different definitions that the police had for the variables and the details of those variables that they provided. And here data checks are particularly needed when working with data from multiple sources. For example, in our data set, different flags and keywords related to the crime and the suspect and the victim did not match because they might draw from different sources of information. Like a flag being recorded in the system that a suspect has a record of domestic violence versus a keyword that says domestic violence. And here you might also then go back into like, how is that data created? For example, is someone flagged as having domestic violence because it was suspected? Or then is the keyword used for proven domestic violence, or is it the other way around? Also, you have to pay attention that changes to the law mean that some prior offenses are no longer notifiable. New offenses are added. So it depends on how far your data, how far back your data goes. And similarly, recording systems get updated for police forces. So new features can be recorded. All features cease to be recorded. So, for example, one force only gave us or had outcomes of charged offenses for historical data. Some other outcomes were recorded. For example, the dash measure was introduced in 2009. So if you have data from before that, then you're not gonna be able to match. So you might have to then truncate. And can we go to the next one? So some strategies for that. You have to know what you have, and you have to be aware of how far your research questions can stretch. For categorical variables, things like frequency analysis can show you the scale of difference. Crosstabs can also show you the extent of where the things match and mismatch. And depending on how confident you are about the reason for those inconsistencies, you can then merge into like different variables. For example, if you have police identity codes and then self-defined ethnicities, you could potentially merge them, but then you have to decide which one takes priority. But you have to document what was chosen and why. And if you merge, you can code across variations, and you get more inclusive but less defined categories. So when your sources disagree, just document which took precedence and why. For example, we also had victim-suspect relationship, which was given for some forces as victim against suspect. For some, it was suspect against the victim. For one force, it was both at the same time. So then you might have to think about recording these into like different categories or higher order categories that standardize your data and make most sense in terms of your data context. So what is best will depend on you. It must be maybe the most complete, maybe the one that seems more trustworthy. But if you choose one data source and exclude the others, this will increase the amount of mixingness, which we already mentioned. But it also reduces the representativeness of the sample, and sometimes it is not possible to merge. So if you are then excluding because of that, you need to make sure you have a good reason why you do that. You can also do subgroup analysis on smaller sections of the dataset and create more inclusive but less refined categories depending on your focus for different parts of the dataset. So for example, we noticed that for some types of crimes against children, there was more information that was available to us. It was more accurately inputted. There were less inconsistencies. So then we were able for certain analysis and different focuses using the data sets to recode and have a different strategy in how we dealt with the variables that we were interested in. So you might have to do that as well. We go over the next one, Ruth. So the last point that we have is granularity, which is the lack of detailed information that was included in the variables. You can only work with what you are given, but when variables lack details, it has implications for the conclusions that you can draw, and it can be very difficult to relate variables to each other, or and you might have to make these very crude measurements, but you might also not be able to relate across police forces. So this granularity can be at the system level and how the software operates, but also at the individual level with different variables having different levels of details. So, for example, investigating outcomes of charge and summons can be recorded by crime rather than by each individual suspect and victim. So then understanding how they're recorded is done is paramount. So then you can only talk about outcomes at crime level, but not at individual level. So then, for example, we're all suspect charged, we're all victims, like, did they go longer in the process, in the criminal justice process? For example, another police force only gave us a data set where eliminated suspects were marked, but the others didn't mark their suspects, their eliminated suspects. So we could have potentially overcounted multiple perpetrator offenses, or we could have overcounted the number of overall offenders because we didn't know exactly how that offender was dealt with in the investigation. And sometimes you can only get the severest crime from the police. So then if there is a rape and there are other sexual offenses happening alongside that rape or previous to that rape or after, then sometimes police forces don't record all those smaller offenses. So you're missing a lot of nuance, and it depends on how much can you actually say about offending patterns. So with that in mind, Ruth, can we go to the next one? You have to then maybe broaden up the scope of your analysis and rethink about what it is that you can do. It is also it's also necessary to understand how the data was created, what level it is at, what variable it has, and what they mean, and how many options those variables have. And then looking at them in terms of missingness and errors will let you know if you can use them. And you have to make decisions based on higher order categories. And also do not discount trying to get information from other police recording systems. So for example, if you know you have certain domestic abuse flags, is there a possibility for you to get the domestic abuse crime recording data set that the police has, which is separate from other crime recording systems? Also, is it possible for you to look at police interviews with the victims or case files, or can you compare it to even other national crime agency system like the VI-class? And then once you know your data, you can take a step back and start being creative about how you go about analyzing it. So for example, if you're interested in multiple suspects, you might not need that variable that tells you that multiple suspects were involved, but you can do that by aggregating suspect IDs and crime IDs. You can also look at repeat offenders in terms of aggregating IDs for the suspect and the crime, so you don't need a specific variable for that. So can we go to the next one? So basically, with all of these inconsistencies and inaccuracies, we recommend that you have a very detailed data governance plans where you document all your decisions and limitations. We found very useful here to have multiple data dictionaries, one for each force that gave us data, one general one of what could be matched, and one where we matched the variables, and one for how every single variable was recoded and what it meant for us and what it meant for the police. So you need to at the very least document your decisions, because you will forget, and it's easier to then to discuss your limitations of what you cannot say based on what you've done. For example, we can't speak in our data of sex crimes. We can only speak about sex reports because not everybody was an offender in our data. Not all of those crimes were crimed. So we need to be careful in the language that we choose. Also, do not go beyond what the data can support, and be realistic about what conclusions you can draw within the data's limitations. So your analysis may need to be broader than initially wanted. And we advise here to allow a lot of time in your project to go back to the police analysts, police data analysts, to try to understand how the data was created and how it was extracted and what it means. And this can take a very long time and can be very frustrating. So do make sure that you have time and patience for that. And the next one, yeah, so I think these were like mainly the general issues that we had, but if you go and read our paper, there's a lot more in-depth conversation that we're having about each of these issues, and get in touch with us if you have any questions. Thank you.
Thank you very much, Ruth and Ioana. See, yeah, George has invited us to post questions. If you do have any questions, please do head to the Q&A section at the top of your screen to start posing your questions. George, No questions yet from the audience, but did you have any questions?
I get to fill the void until people start typing questions into the chat. So I'll tell a few jokes. No, I'll great work, great presentation, huge number of data challenges, clearly. So you talked a lot about the data prep, but you've obviously done some analyses of these data as well. So to what extent would a key result move around as you gradually fix up the data? You start with a kind of completely naive analysis and you gradually impute the data and so on. Were you finding kind of quite different answers to your research questions as you fix the data?
I'm trying to think. Yeah, I mean, I think it does change over time because certainly, and I know that Ioana had this as well, where you think that you've done something, that you've come up with a solution, that you've done your analysis and it's correct, and then you would be out, doing something completely different, and then suddenly you'd realize, oh, actually, we didn't account for this, we haven't aggregated this, and so it changes all the time. And I think as you get to know the data more, the sort of questions that you ask of it and how you temper your analysis and the solutions also changes, and you can get more sophisticated sometimes, but also like knowing the limitations of what you can say, I think becomes clearer as well over time.
Yeah, and I think in terms of that, maybe I forgot to mention it, but for us, what we found useful is working with the SPSS syntax and never deleting any of the syntaxes that we have, because it saves us a lot of time from redoing the same thing, the same filtering, the same selection, the same sort of analysis a lot of the times. And sometimes you might not remember how you got to a specific result. So it's nice to have to go back and see how that was done, or if you want to take the same sort of strategy for a different type of analysis on a different subsection of the data. That's also an advice that we have.
Yeah, so I mean, one of the things you've said quite rightly is that sometimes you have to adapt your analysis and pull back from your initial bold aims of what you're going to do, because the data just simply aren't good enough. So I'm guessing there might be a tension with the police forces themselves, or whoever's commissioned the work. They want answers to big policy questions, and it becomes a point where the limitations are so great that you're going to have to push back. That's not really the skill set that we develop as academic researchers. So you speak about that a bit?
I mean, Ruth knows more about like the complete ins and outs with the home office when we were discussing with them over the years. But yeah, I think it's no, go on.
I was just going to say, I think there was a lot of tension because certainly a lot of the results from Soteria were critical of the police, and it was about dealing with that sensitively, because at the end of the day, they're your partner, they've supplied the data, they've given you access, and so you have to, stick to your guns in terms of if it's saying one thing, you can't say it's saying another. But there's ways of discussing that with them and thinking about how it can be presented constructively rather than critically, I guess. But yeah, there's some stuff that you just like, we can't do. You need to improve your data recording practices. And I think that they would admit to that as well when you see the amount of missing data. But for them, these sorts of questions, I think it was quite unique for them as well, because I don't think they use their data like this. So I think it's been eye-opening for them in terms of just the amount of information they have and what it can be used for, because like I said in the presentation, it tends to be for investigative purposes. So they're not sort of looking at patterns and, predictors and things like that. So I think that was quite good for them to sort of think, oh, actually, yeah, there's value in this in a different way.
Fabulous. Thank you. I'm Jonathan. I'm presuming you want to get cracking with the second presentation.
Yeah, I say let's do that. I know we've got any time
thank you again
left.
for that wonderful talk. Thank you.
Perfect. And Ruth and Ioana, if I could just ask you to respond to Lucy and the Q&A who's just asking for a link to your research. She says it's already very helpful for her at the start of her PhD. So thanks for that. So next up is Natalia Lopez-Hornicle from the University of Bath. Over to you, Natalia.
Okay. Can you see the presentation well and hear me well? Just in
Yes,
case?
we can.
Okay. Okay, thank you very much. So, well, thank you everyone for attending this session. So, I'm Natalia Lopez-Hornicle. I'm finalizing my PhD at the University of Bath. And when I saw the call for the presentation, I thought it was a good idea and great to have this space to discuss the challenges that we encounter in the research that we are developing. And I was thinking what was challenging for me. Back in 2018, when I was starting as a researcher assistant on a project in Chile, we have to work with large-scale assessment. It was the first time for me. And the first step was to merge the data. And you cannot imagine how frustrating it was for me because, there is a huge amount of data in large-scale assessment. So it was really challenging. And I wanted to show you a little bit how creating steps helped me in this task. And recently, in 2022, I realized there was a super interesting analytical tool to work on intersectionality from a quantitative perspective, which is MIDA. And I want to say that it's super interesting and funny, but I'm still a beginner, and I will talk about one possible way to explore how we can use these methods in large-scale assessment. And of course, this is still work in development, so I'm very open to receive constructive feedback. And of course, it's more than an honor for me that George Leckie is the chair of this session. Okay. So this is more or less the agenda. I will cover what are large-scale assessments, ICCS, merging datasets. I will talk a little bit about the code, the MIDA analysis, and the application that I'm doing. So the international large-scale assessment, we refer to cross-national standardized assessments that are coordinated internationally. So we have very complex sample designs, student testing in school, that means stratification, weights. The data requires the inclusion of weight because students and schools have different probabilities of selection, and some groups can be overrepresented. So usually these tests are composed by different questionnaires, including cognitive tests plus scales that want to measure some attitudes, dimensions, and they are designed to infer to the population. The relevance, well, of course, it allows us to have a huge amount of data to compare different outcomes across countries. And the idea is to provide evidence and data for policy intervention. So the International Civic and Citizenship Education Study, the ICCS, is the one I'm using and I have used in my thesis. So the target population here are students around 13 and 14 years old. And the purpose of the study is to understand how well prepared adolescents are to undertake their responsibilities as citizens. It has several waves. I think the first one was 99. After that, 2009, 2016, 2022, the upcoming 2027. Okay. So when we are talking about merging data, so first of all, it's important to have official source of the data. So if you are interested in the IEA data, they have a huge repository with all the different studies that they manage globally. And each they have different types of data inside of ICCS. So you will find teacher questionnaire, the student questionnaire, the principal questionnaire as well, and they have a specific set of questions for Latin American students and European students. So there are different data levels, no? That is the meaning of having different sources of data. So in the student level data, we have the student international data, the regional models. Also at the school level data with the principal, you will find one principal by school. So the information provided by this person describe the school as a whole. Then the teachers is a little bit more challenging if you want to analyze variables connected with them, because there are several teachers per school, and the numbers, the minimum and maximum, can vary depending on the context and on the school. So if you want to include their information in the data, that means that probably you will need to aggregate the variables in which you are interested as school indicators. And to guarantee merge, the data, and this is fundamental, comes with identifiers, no? So the student ID identifiers, that needs to be unique across countries. And this is not guaranteed. So when you download the data, it's very likely that you will find a student with the same ID in Italy and in Spain. So you need to be careful with that, and the same happens with the schools. Okay, so I will try to explain how I created this. It's very important to say that my supervisor, Dr. Diego Carrasco at the Pontificia Universidad Católica de Chile, was a person that helped me to understand these steps and construct the different steps of the syntax. Okay, so first of all, we need to recognize the files that are of students in the data that you have. So in the ICCS, you will have that all student data. And this is a very important point that I didn't say at the beginning. I'm just focusing here on student data because of the time. Otherwise, I can use the whole session for all the merge. So this is the student data that I will use afterwards for the analytical tool that I was talking at the beginning. So in the ICCS, you will find that the students, all the data of students have exactly the same prefixed. So you can recognize them in R for this pattern. And yes, you are reading from SPSS files to R, and you stack them. Second, we have labels and the description of the variables when we stack files of different countries. Some of them eventually can be lost. So what we do here is to take labels from one of the clean reference file, and we apply them to the international dataset. Then in the third step, we check just like a diagnostic, whether the original school codes are unique within countries. So we count, no, how many distinct schools codes exist and if they are consistent. And you can create this, so they will tell you if they are consistent or not. Then we create country index, which is very important to make them unique across context. And here, basically what I'm doing here is to create new identifiers, ensuring that strata, school, and students are uniquely defined across countries. So one for the country here, then you create one for strata, then for schools, and finally for students. So again, I think this is very important and was something that I was taught by Dr. Carrasco. It's very important to check every time. So you create something new in the data, then you check if it's consistent or not. And you see if there are any duplicate ID. It could be simple as that, just counting. If you have one ID that is more than one, then there is a duplication that you need to take care and go back to the previous step. Then, if you are interested in the European model, you basically do kind of the same. You recognize the data that you are using for this module. Then it's important to collect as well the labels to make them consistent. Yes, and then you can create a table just to link the original student identifiers to the new international student ID, and then you just copy the information to the international data. Kind of the same for the Latin American module. So you need to recognize the prefix of this particular module. You read, you stack them, copy the labels. You can create this index, and then we attach to the module data the information that you already have. And finally, it's very important as well to include the weights. You will see here a huge list of weights, but just some of them are the essential ones that you need to work with. So the total student weight, then within school weight components, and the school level weight. And it's very important to say that the ICCS provides guidelines to create these weights, indicating which of them is what. Okay, so apart from that, because I didn't put the whole code there, but finally you need to save, of course, in a safe place, your data. You have your student data. So I will move to the analytical tool in which I was interested. So this is MIDA, multilevel analysis of individual heterogeneity and discriminatory accuracy. And I will refer a little bit about the background first. So, okay, I'm coming from the interest in intersectional studies. So intersectionality, what it does is a perspective that looks to identify how systems of oppression such as sexism, racism, and classism intersect and give a space to privilege and disadvantage relations. And usually what you do is that social categories such as gender, class, race, ethnicity intersect and form the social locations that experience these possible systems of oppression. So usually what we find in the literature is that from quantitative research, there is, of course, a huge line that comes from the tradition of epidemiology, health outcomes, and also recently Keller, she moved the focus a little bit, or took the analytical tool to the educational field. But it's not very common that you use the intersectional approach to understand the addition to gender equity attitudes. So here is kind of the new thing, because we are moving the focus just on achievement or cognitive outcomes towards a more evaluative and affective dimension. And attitudes actually are part of the civic and citizenship education framework. And there are previous pieces of research that have shown intersectional analysis with a quantitative approach, but it's not very common. And why they are important? Well, they are connected with behaviors. Among adolescents, this is critical because it can, if the attitudes tend to be more traditional, that can create, for instance, violent or risk behaviors among young male, also more submissive roles or career expectation in the case of females. And there is evidence as well how these attitudes can be connected with the gender equality of the countries at the contextual level. Okay, so intersectionality, how it has been studied. So usually what has been done is to use multiplicative terms in regressions with the main effects. So yeah, you introduce the main effects and a full set of interactions in your model. However, this comes with methodological limitations. So the main one is scalability, because the more social categories are considered, the higher the number of parameters that will be needed to represent all the possible interaction effects. And in that sense, it's not a parsimonious technique. Interactions need more samples and statistical power to be done correctly. And the interpretation, and this one for me was, in the past was very tricky, becomes very complex. So MIDA, basically what it does is a multi-level model, and you are creating the social strata as second-level units. So the membership of the students will imply the exposure to certain advantages or disadvantages. So, for instance, in one stratum, you will find all the females that have immigrant background and whose parents have high level of education, and also at home they have high number of books. So this is more parsimonious approach, because we can get the means for each groups. And if the groups present different sizes, which will the case, just simply you can see higher standard errors for such means. So yeah, definitely will help us to account for the lack of sample balance between the groups, while a linear combination of terms. So here I will use only the case of Chile with ICCS, and the outcome variable, as I told you before, gender attitude, which is a student endorsement of gender equality. So this is the scale. It has different items, so such as women and men should have the same rights, or for instance, women should stay out of politics. And I'm also using, to construct the social strata, gender, immigrant status, parents' education, and home literacy resources. I dichotomize each of these variables. And of course, this is very important to say, so there are very interesting and useful guidelines in the topic. So one is to conduct this intersectional analysis oriented to health outcomes, but you can see all the steps with very deep explanations of how it works. And also I found relevant Keller because it's connected with the educational field. So the models, of course, as a multi-level normal model, we have the null model and the second model, and the first one will allow us to see the ICCS, the intra-class correlation, to see how much of the variance in the outcome depends on our social strata. Okay, so before I show you the results, I will try to be quick here. So first of all, the challenges that comes with large-scale assessment, also could be all other types of data, but missing data. So why is a challenge? We have key background variables. For instance, we have immigrant status, and this variable comes with a lot of missing values, obviously. So we are not willing to reduce the sample by dropping students. So also because we cannot have eventually missingness at random. So basically here, what I did was to diagnose the missingness, so quantify how much of the missing data exists as a whole in the data set, but also by variable. Then, of course, you need to be sure that the variable types are correct. That means if some of them are binomial or not. Then in the model, you specify a two-level imputation. That implies that you need to indicate the ID of the school as the cluster variable. And of course, in this stage, we prevent to contaminate the imputation with the weights. And then we run the multiple imputation and we extract completed data sets. In this case, I use 5 plausible completed data sets. The second one is the survey weight. So of course, in a survey like this, students are not all equally likely to be selected. Some schools are sampled with higher probability. Some students represent more people in the population. So it is important to have in consideration the weights. And the MIDA model, what we did here is that we estimated without directly inserting the survey weights into the model, because this is a Bayesian model. So Bayesian model doesn't include survey weights in the same way as the sign-based estimator does. And what we get from the model is that we can predict stratum means on the model's case. So these are Bayesian posterior summaries. And then we use the survey weights after decimation to expand those stratum estimates to the population. So we apply it afterward to the predicted means. Okay, then regarding the strata, scars, and convergence, well, this also happens when we have combinations that include few students. Some of them can have 0 eventually. So for this one, we produce the post-estimation summaries, and we exclude eventually empty strata because there are not students to support an estimate. And finally, the estimation and pooling. So basically, we use the Bayesian multilevel model. So the key outputs are posterior distributions. And what we did here is that we feed the model separately in each of the 5 imputed datasets, and then we pool the results using posterior-based pooling. For coefficients and predictions, I stack posterior rows across imputation with bind rows. And after that, we summarize with posterior means and quantiles. I'm sorry, so these are descriptives. Here we have the construction of the strata. So you will have 16 groups with different combinations of variables. If you have boy, non-immigrant, with low parents' education, low numbers of books at home, etc. You have here the null model. Sorry, this one, I don't know why it doesn't show. The point should be here. But the null model gives us that the ICCS was 23%. And then when I add the main effects, it is reduced to 121. I know it's very low, but I will consider that is an unignorable portion. Yes, sorry, here it is. And the main effects are consistent with previous literature. So females have more chances to be egalitarian. When you have immigrant background, you have a negative association. But if you have more with an environment with more education, you probably will be more egalitarian as well. And here you can represent the different intersectional strata. So for instance, the 12 has the higher gender equity. If I go back, the 12 was to be girl with non-immigrant background, and you have parents' education high and also high level of books at home. And that contrasts with 5, which is also probably, boy with immigrant background and with low resources at home. Yes, so here are the weighted predicted means. And basically, to finish, ILSA data is a substantive methodological step rather than a technical formality. So you need to be clear about what will be your analysis to do it in that order your merge. And MIDA provides a parsimonious framework for intersectional analysis in ILSAs. You can use it in ILSA as well, which is very niche, but ILSAs can benefit as well from its application. So thank you very much, and sorry for the extra time.
Thank you, Natalia. Thank you for your talk. It was very nice to see that even with research-ready data, it is still hugely complex. Yeah, so the two talks are very different in terms of the underlying data, but your data is meant to be research-ready, but it's not. So as you point out, you need to worry about the survey weights, the missing data, even fixing up the IDs. So it's still complex. I did have a question about the analysis. So one of the dimensions you were interested in was number of books, and you dichotomized that more or fewer books than 100. So a lot of quant social science is a bit sniffy about people, turning a continuous variable into a binary variable to help the analysis kind of thing. So do you want to come back at me on that? Or did you explore sensitivity at all?
So you mean this one?
Yeah, the number of books, yeah.
I will be very honest here. So I dichotomize them in order to be more straightforward with the method and to make it easier to interpret. But I'm very happy to hear if you have suggestions regarding sensitivity tests for this one particularly, because I know I did a huge division between having up to 10 books and then 11 onwards.
Yeah. So I think it's you got the point exactly, which is this trade-off between trying to make an analysis useful by simplifying, but at what point do we overly simplify and trying to, it's a hard one. So yeah, I think in a journal article you might do sensitivity analysis to a different cut point, or maybe having 3 categories, low, medium, high for it. It's the kind of pushback that a reviewer might give, I guess. One other question from me, unless anything's coming in on the chat. So you looked at Chile during your PhD more generally. Did you look at any other countries for how results differed across countries? Or?
So no, this is the final paper of my thesis, and it's the only one that includes the intersectional analysis. I'm using Latin American module, but I'm using other types of analysis. It will be super interesting to see what is going on in other contexts. But also I think that is an interesting point to explore in the methodology, maybe, because what it happens if you include an additional layer in the analysis, that will be more complex, no? I'm not sure if it's feasible with this data, because in 2016, we only have 5 countries. Maybe using the whole pool of countries of data could be something. I don't know if George, do you have any suggestions regarding that maybe as well?
I think just repeating the analysis you've done for another country in Latin America, and just seeing how consistent the patterning of the results is or not, and therefore what that says about or your isms or the sexism, racism, classism. I think that's an interesting line of work. Thank you very much. I think I noticed we're at 2 o'clock. So
thank you.
I think I'll hand over back to Jonathan.
Thank you very much, Natalia, and thank you, George, for those questions as well. Right on the dot. So I don't see any more questions coming in. I have just put a link to a survey in the Q&A section. It's very helpful, not just for us to know how you thought the session went, but also what are the training you'd like us to try and offer in the future. So really appreciate if you could fill that out. Hopefully it won't take you too long. But I think I won't keep you. So thank you very much once again to all our speakers, to George, and thank you to everyone for coming along.